Hello everyone, today in this video we will solve these questions of sets chapter, remaining questions. Write in roster form. If the set is given like this, b is equals to x such that x is an integer and the values are given from -2 to 5. So this, which form is it? It is in the set builder form. This form is called as set builder form because here we have given the rule. So this is set builder form. What is asked in the question? It's asked that we need to write it in roster form. Roster form is nothing but listing out all the elements, tabular form, also called as tabular form, wherein we list out all the elements, means we will write the elements separated by commas. So how do we write? B is equals to, again, okay, when we are writing in roster form, again this flower, these braces should be there. Then x is an integer. What are integers? Integers are the numbers which include both positive and negative. So they look something like this: negative numbers. Okay, so all the negative numbers, 0 and 1, positive numbers together are called as integer. So here what is he asking? X is an integer that is lying between 2 and 5. What we have to observe is it given less than or equal to or just less than? Here it is less than, means -2 is not included. We should not take this. So what should be taking? We should start from -1. Let me write furthermore, 6, so on. So it, and x value is less than 5. 5 means we should not be including 5. It is because it is less than 5. So the values are -1, 0, 1, 2, 3 and 4. Why not 5 and why not 2? Because here the symbol that is given is less than. -2 is less than, means -2 is not included, and then 5 is less than 5 means 5 is also not included. If at all it was less than or equal to, then we would have included. So how we will write? We will write the values 0 separated by commas, 1, 2, 3 and 4. So this is the way we represent a set in roster form. So whenever we are writing the set in the roster form, for just the recapitulation, these are all these items are called as elements. These are called as elements, and each of them are separated by commas, as well as no element can be repeated. No element can be repeated. They should be written in the bracket, and order does not matter. So the same set I can also write it as 0, 1, 3, 2, -1, 4. As per our convenience we can write the order. The order does not matter. Now coming to the next question. Here A and B are two sets given. We need to find A minus B and B minus A. So for this, let us draw this in the form of Venn diagram. I will show you a trick which is quite easy. So how do you draw the Venn diagram? The rectangle represents universal set. And how many sets do we have? A and B. These are the two sets we have. So each set is represented by a circle. Now let us check, are there any elements that are common in these? 6. Here also 6 we have. Then next is 12. Here in set A we have 12, and set B also we have 12. That's it. We have two elements that are common in these. So these circles will overlap each other, because when there are common elements between two sets, these circles will overlap each other. As we all know that the rectangle represents universal set, and this circle represents individual sets A and B. These circles are overlapping because there are some elements which are common to both these sets A and B. So, what are the common elements? First of all, you have to identify what are the common elements. So, 6, those common elements should be written in the overlapping area. 6 and 12 are the common elements. Now, the remaining portion of the A set, circle A is there, na? That in that you will be writing the remaining elements of A which are not common. So, what are left out? 2, 4, 8, 10 and 12. So, those elements we will be writing here 2, 4, 8, 10 and 14. Now, look at the set B. In this set B also we will leave the common elements and write down the remaining elements. Here in this case the remaining elements are 3, 9, 15 and 18. Why I have suggested writing this in the Venn diagram form? Because it will be easy to find out A minus B, A union B, A intersection B, B minus A, everything. From this we can easily give the data for that. So, in this question what did he ask? He asked us to find A minus B. So, what you have to do, just look at the figure. Look at the figure. This is the set A. This is completely, the first circle represents set A. The overlapping, in the overlapping area, the data that is there is A intersection B. So, write down, in order to find the elements of set A minus B, just write down, note down the elements that are in A except those elements which are in the overlapped area, except those elements which are in the overlapped area. So, our set A minus B will have the elements 2, 4, 8, 10 and 14. These are the elements that will be there in the set A minus B. A minus B set will comprise of these elements. Now, let us find B minus A. B minus A will be the set which has the elements. Leave the overlapping area and write down the remaining elements of set B. What are those? 3, 9, 15 and 18. These are the elements of set B minus A. So, it is easy to find out various elements like A minus B, B minus A union B, A intersection B, everything can be find out easily once you are able to draw this Venn diagram. Coming to the next question, here let us read the question. If A is equals to x such that x is a factor of 18, then find n of A. Whenever you are solving the questions in set chapter, mostly he will be using the terms like factor and multiple. So, you should be aware of the terms factor and multiple. Let us first discuss what is factor, what is a factor and what is a multiple. So, coming to the term factor, it means if you have, let me give an example, 3 4s are 12, right. So, a factor is a number which divides a given number completely. This is the definition. So, if I take this number 12, if I divide it by 3, 3 4s are 12 and the remainder is 0. And if I take the number 4, if I divide 12 by 4, 4 3s are 12 and the remainder is 0. It means if you take a number and divide by another number, if the remainder is 0, then this divisor is called as the factor. If a number, or in other words, if a number is completely divisible by another number, that number is called as factor. Here 3 is called as the factor of 12 because on dividing 12 by 3 you are getting 0. On dividing 12 by 4 you are getting 0. So, 3 and 4 are the factors. In general, by just looking at this you can say that you need not even draw this, you do not even calculate and divide like this. When you have a table like this, 3 4s are 12, what does it mean? These two numbers are multiplying each other to get the number 12. So each of them are the factors of 12. Each of them are the factors of 12. Whereas when I say multiple in the same thing, 3 into 4 is equals to 12. So this 12 is called as the multiple. The number which is obtained by multiplying a number with another number is called as multiple. By just looking at this, you can say that after equal to whatever you have, that is the multiple, and the numbers which are multiplying are the factors. These are factors. The product is the multiple and these are the factors. I hope that's clear. Now coming to our question. So in order to, if at all you get confused about what is a factor and what is a multiple, just write down some table like 3 4s are 12. In this you should be knowing that 3 and 4 are factors and 12 is the multiple, right? So wherever you have a doubt, you just take an example of it in order to clarify that. Now coming to the factors of 18. So A is a set. A is a set in which all the elements are the factors of 18. First and foremost thing is 1 is a factor of all the numbers. So 1. So 1 into 18 you will be getting 18, right? So 1 and 18 are the factors. We also know that 2 9s are 18. So 2 and 9 are factors. Then we also know that 3 6 are 18. So 3 and 6 are also factors of 18. And 6 6 are 36. So we already have 6, so we will not write 6. So these are the factors of 18. Now he did not just ask us to find the roster form, he has asked us to find the n of a. So n of a we cannot directly make out from this. So what we have done, we have converted into roster form. Then now we will find n of a. What is actually n of a? N of a means, that is nothing but, this is called as cardinal number of set A. Cardinal. What do you mean by cardinal number? Cardinal number is the number of elements in a particular set. If I say n of a, that is the number of sets, the number of elements in set A. So let us count 1, 2, 3, 4, 5, 6. So n of a here in this case is 6. Okay. So coming to the next question, this is also one of the important questions. So list all the subsets of the set B. Here the set is having 4 elements. What is that? P, Q, R and S. So you in order to know actually how many elements, I mean how many subsets we get, we have a formula. B is equals to 2 to the power of n, where n is the cardinal number. Now just now we have discussed what is cardinal number. N is nothing but the number of elements in this set. So 1, 2, 3, 4. Here in this case n is 4. So let us just calculate how many subsets we will get. So 2 to the power of 4 is nothing but 2 into 2 multiplied 4 times, right? 2 into 2, 2 to the 4, 4 to the 8 and 8 to the 16. Totally we will get 16 subsets. And now how to write these subsets? Let us write down. Subsets of set B are null set is a subset of every set. So whenever he is asking subset, write down the null set first. And also we should be knowing that a set is a subset of itself. It means set B. Directly you can write B, or you can list out the elements P, Q, R and S. Okay. Null set is a subset of every set. So we will write in among the subsets, we will write null set as the first set. And also every set is a subset of itself. So we will write the set itself, here it is B, or you can list out the elements like this. then we will mention each of the elements as the set, like a set with one element P, one element will write Q, then R, then S. Now let us make pairs, two elements will take P comma Q, then P and R, then P and S. Next move on to the next letter Q R. We are forming sets of two elements each. Then we will write all the possible combinations Q R and Q S. Then next is R S. R S. Then we will take, as all the possible combinations are completed, see P Q, P R and P S, Q R and Q S, then R S. These are all the possible combinations. Now let us take three elements at a time. So P Q R, P R S, then Q R S, P Q R, Q R S, P R S. Okay. Now let us count how many sets are completed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. One more is left. PQ, PR, PQS is the, we missed out this one. So the PQS is the last subset. So let us count now. So here it is 1, all this is 1, 2, right? So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. As we have seen that there will be 16 subsets, we have listed all of them. So let me take one more small example, and in order to explain you very clearly. Suppose we had only two elements. Suppose the set is A is equals to 1, 2, right? So here n is 2. So number of subsets will be, number of subsets will be 2 to the power of n, that is nothing but 2 to the power of 2, it is 4. 2 into 2 is 4. So let us list out the elements. Now you have to see me how we what are the subsets, because we know that null set is a subset. Null set can be represented by empty braces or phi, empty braces or the letter phi. Okay, what's that? The letter phi. Then the set itself, that is 1, 2. Then we will write the individual elements 1 and 2. Then we will write pairs, because already we have only 2, so it is already listed. So totally how many did we get? 4. 1, 2, 3 and 4. So this is the way we find the subsets of any set. Now coming to the next one, what is a null set? We should be able to define clearly what these are. Okay. First and foremost thing I want to explain, what is to be discussed is, let this be set. If I am talking about set, so what is a set? A set is a well defined collection of items. A set is a well defined collection of elements or items. Okay. Now in this set, all the items in a set are called as elements So when we are defining a set, we better call it as a well defined collection of distinct elements. It is distinct items, elements. These items are called as elements, and when we are denoting a set, each element is separated by comma, and comma is nothing but, what is comma? This symbol comma, and the order does not matter. So the order of these elements does not matter. So what are sets? A set is a well defined collection of distinct elements. If you want to give the prompt definition of set, what you have to say? A well defined collection of distinct elements is called as set. Whenever you are representing a set, all the elements are separated by commas, and the name of the set is given using a capital letter. If I want to give an example of a set is denoted by, the name of the set is given as in capital letters. Suppose I have a set A is equals to X, Y and Z. So these X, Y, Z are called the elements, and they are separated by commas. No element is repeated, and the name of the set is given using capital letter. Now coming to the first, as I have explained, the first one is set. Coming to the null set. What is a null set? A null set is a set which has no elements. A set with no elements is called as null set. A set with no elements is called as null set. Now how do you denote a null set? By using empty braces or by using the letter phi. And the most common mistake that is done by most of the students is they write this phi inside the braces. This is the wrong notation. This is the right notation. You can write either these empty braces or this letter phi. Now what are finite sets? Finite sets are the sets in which there are finite number of elements. You means countable number of elements. If I take a set with finite elements is called as finite or countable elements is called as finite set. If I take a set, for example, A is equals to 1, 2, 3, 4, 5. Is it a finite set? Yes, because we can count the number of elements in it, and that is nothing but, how much is it? N of A is nothing but number of elements. Cardinal number of A is 5. We can count, we are able to count it. Suppose if I take another set, N is equals to, what is N? Natural, set of natural numbers, 1, 2, 3, 4, so on. We don't know where it ends. So these type of sets are called as infinite sets. What are those called as? Infinite sets. Infinite sets. Infinite sets are the sets in which we cannot count. A set with uncountable elements. Like the set of natural numbers, like the set of whole numbers, like the set of real numbers. Okay. Now what are disjoint sets? Disjoint sets, the sets with no common element. If we take two sets, okay, the sets with no common elements between them, that is, for example, A is equals to 1, 2, 3. Okay. A is equals to 1, 2, 3 and B is equals to X, Y and Z. Is there anything common in between these sets? No, there is nothing. So, A and B are disjoint sets. We can say that A and B are disjoint sets. Now, last one is cardinal number. What is cardinal number? Cardinal number is nothing but the number of elements in a set is called as cardinal number. Number of elements in a set is called as cardinal numbers. If you take this same set A, so what is the cardinal number of A? 3. Now cardinal number of B is, again here it is 3. So the number of elements in a set is called as its cardinal number. Hope that's clear. Next one, in this question, A and B are two disjoint sets. What do you mean by disjoint sets? It means the two sets have nothing in common. That is, common thing means intersection, right? A intersection B has nothing in common, means it is empty set. When you form the set A intersection B, you will get a null set. Now, because in this set we have nothing in common, right? So intersection B will be nothing. And here in the question it is given that, what is given? N of A union B is given as 12. N of A is given as 7 and N of B is given as x plus 2. But we know that N of A union B is equals to, what do we have to find? Find x, okay. N of A union B is equals to N of A plus N of B minus N of A intersection B. You can, in order to understand this more clearly, you can take sets and you can find these and you can verify as well. In the upcoming questions, we will be discussing about this. So, N of A union B is equals to N of A plus N of B minus N of A intersection B. Here N of A union B is given as 12, N of A union B is given as 12, 12 is equals to, how much is N of A? It is 7 plus N of B is x plus 2, because we know that A intersection B is null set, because these are disjoint sets. In a disjoint set, N of A intersection B is null set. So, N of A intersection B is 0. When the two sets are disjoint, their intersection will be, the cardinal number of their intersection will be 0. So, minus 0. So, how much it will be? 12 is equals to 7 plus 2 is 9 plus x. Let us write RHS first. 9 plus x is equals to 12 and x is equals to 12 minus 9, that is nothing but 3. So, the value of x is equals to 3. In this question, from the figure, find N of A, N of B, N of A union B and N of A intersection B. It means we have to find the number of elements in set A, set B, set A union B and the set A intersection B. First of all, let us form the sets. Looking at the Venn diagram. In this, set A is nothing but, we will write the elements here. As you can see here, all the elements within the circle, including the overlapped area, this complete circle we are talking about. So, all the elements which are there inside these circles represent the set A. So, what is there? 1, 2, 3, 4 and 5. So, let us list out the elements of set A. So, 1, 2, 3, 4 and 5. Similarly, in order to write the set B, how do we write it? We will write all the elements of set B, that is 6, 7 and including these values 4 and 5. So, it is 4, 5, 6 and 7. Now, n of A is nothing but the number of elements in set A, that is, as you can see, it is not 4, it is 5. 1, 2, 3, 4 and 5. Totally, the number of elements in set A is 5. Here in set B, how many elements are there? 1, 2, 3, 4. So, the number of elements in set B is 4. That is, the cardinal number of set B is 4, whereas the cardinal number of set A is 5. Now, looking at the, by this question you will also be able to find out how you can write the set, form the set A union B. So, A union B comprises of all the elements, it has all the elements of set A and B. Whatever is there in these two circles, that should be written as set A union B. That is, what is there? 1, 2, 3, 4, 5, 6 and 7. So, A union B will have the elements 1, 2, 3, 4, 5, 6, 7. And as you can see, n of A union B is nothing but, let us count, 1, 2, 3, 4, 5, 6, 7 elements. So, total number of elements is 7. So, n of A union B is 7. And let us find A intersection B. So, which area represents A intersection B? This overlapped portion represents A intersection B. So, what are those elements there? 4 and 5. The overlapped portion has only 2 elements, that is 4 and 5. Now, we can also find out n of A intersection B. That is nothing but the number of elements in this set is 1 and 2, 2 elements. That is it. Next one, here two sets are given, that the set A has 3 elements, those are P, Q and R, and the set B has 3 elements, that is Q, P and R. What is asked here? Are they equal? So, by the definition of set, we know that the order of the elements does not matter. In both the sets A and B, we have the same element. Here we have P, here we have P. Here we have Q, here we have Q, and R and R. So, the elements are same, but the way they are arranged is different. So, we already know by the set definition that the order does not matter. So, we can say that as all the elements of A are there in are there in the set B, we can say that A is equal to B. Why? Because order of elements, order means how they are placed. Order of elements does not matter. You can write first thing last, last thing first, nothing will happen. Does not matter. Okay. Now, coming to the next question, we have here set. What do you mean by this? This is the null set, right? A is a set which has 2 elements, 1 and 3. B is a set which has 1, 5 and 9, that is 3 elements, and C is a set which has 4 elements, 1, 3, 5 and 9. We have to insert these, in these fill in the blanks, we have to insert these symbols. What does each of them represent? This represents subset. The meaning of this is subset. Subset. Sorry, not here. The meaning of this term is, this symbol is, it means it is subset. This is the symbol for subset, and this is the symbol for superset, and this is a symbol stating that it is not a subset, not a subset. Subset means all elements of set A. If I say that A is subset of B, all elements of set A should be there in the set B. If I say B is a superset of A, means B has more elements than set A, means including all the elements of set A, it has more elements, means see the same thing can be written in two ways. A is subset of B. When A is subset of B, you can call B as superset of A. Let us look at this. We know that pi is a subset of all the sets, isn't it? So pi is subset of B, we can write. And look at A and B. A has two elements 1 and 3 and B has three elements 1, 5 and 9. But all elements of A are not there in B. Neither all elements of B are there in set A. So A is not a subset of B. The third thing is comparison of A and C. A has 1 and 3 and B has 1, 3, 5 and 9. It means all the elements of A are present in C. In addition, we have two more elements. So can we say in this case A is a subset of C? Yes, because all elements of A are there in B. So we can say that A is a subset of C. Coming to the fourth option, that is B dash C. What is B? It has three elements 1, 5, 9 and C has elements 1, 3, 5, 9. Here we have 1, here we have 1 and here we have 5, it's there in C also, and 9 and 9. In addition, we have one more element, that is 3. So we can say that B is a subset of C. B is a subset of C. Now look at this question. It's very interesting. Show that the sets C and B are equal. First of all, in which form is it given? The sets are given in set builder form. Let us write in roster form. So when we write this in roster form, C is equals to, we'll list out the elements in these braces, right? So we have the letter A. Let us check these letters A, S, again we have S. So, but when you are representing in a set, you should be writing element only once. Nothing, no element can be repeated. S is already there, A is already there, we will not be considering again an S we have. So we will not be considering that too. We have a new letter I, new letter N, A is already taken, T is a new letter, I is already existing, O is a new letter. So what are the letters we have in this? A, the elements are A, S, I, N, T, O, N, and we cannot take N because already it is taken. No element can be repeated. So how many elements do we have here? 1, 2, 3, 4, 5, 6. Coming to the set B, it has the letters station, S-T-A-T-I-O-N. Let us check for the elements of set B. S, T is a new letter, A is a new letter, T is already taken, so we will not be considering that, I, O, N. These are all new letters. So we will be taking elements as S, T, A, I, O, N. Now as you observe here, A is there, A is there. Here we have S and here we have S. Here we have I and here we have I. Here we have N, here also we have N. In the set B, C we have T, in set B also we have T. O we have T, in the set C we have O, and in the set B also we have O. So each element of A, C is also there in the set B. But what is the difference? The order is different. So it's not an issue. The order does not matter. So we can say that set B is equal to set C, because all the elements of set C are also present in the set B.